In this lecture, we'll be discussing about operating system generation and system book. So we have been discussing about operating systems in the past few lectures, and now we'll be seeing in what ways can we design an operating system. So basically, there are two ways or two approaches in which an operating system can be designed. So the first approach is design, code, and implement an operating system specifically for one machine at one site. So in this approach, what we are doing is we are designing an operating system specifically for one machine. So we are just taking into account, or we are just looking at one machine, and we are seeing what are the requirements of that machine, and we are designing the operating system specifically for only that one machine. So this may be a good approach if you are only concerned about one machine. But if you think of it in a larger perspective, this may not be a very efficient design technique because we want operating system to be able to work in multiple systems without having to redesign it. So we come to the second approach. So in the second approach, operating systems are designed to run on any of a class of machines at a variety of sites with a variety of peripheral configurations. So in the second approach, we are designing the operating system in such a way that it will be able to run on any of a class of machines at a variety of sites with a variety of peripheral configurations. That means this operating system will be able to run on a class of machines or a variety of machines, irrespective of their configurations or irrespective of the kind of machines that they are. The operating system will be able to be run on them easily. So for example, let's say that you have an operating system. Let's say that you have downloaded the Mint operating system and you have it on a CD. And you install that management operating system in your computer using that CD, and it is installed. Now let's say that your friend is having another with different kind of hardware configurations and a completely different machine. And even on your fringe system, you are able to install that index screen operating system from that same CD. So we see that, irrespective of the machines that you have, the operating system can be installed in both of these machines. So this is the second way we designed the operating system, which is a much more efficient and also the most common design technique that is used today. Now the question that may come to your mind is that if the machines are having different hardware configurations or different peripheral configurations, then how will the operating system be installed in these different systems if their configurations are different? So the answer to this question last year, the system must then be configured or generated for each specific computer site. A process sometimes known as system generation or system is used for this. So in order to solve that problem, there is something on a system generation or system. So the system generation helps in generating the operating system in such a way that it will be compatible or in such a way that it can work for that specific machine. So with the help of the system, the operating system will be generated in such a way that it will be suitable for the specific computer on which you are installing it. So that is what system generation or system is used for. So there are some kind of information that must be determined by the system program so that it will know how to generate a particular operating system for a particular machine. So let us see what are those information that must be determined by the system program. So the following kind of information must be determined by the system program. First of all, what CPU is to be used. So the system program must find out what is the processing unit that has to be used in that machine, because there are different kind of processing units that we have. So depending upon that, the operating system has to be generated. So assistant program will determine what is the CPU that is to be used. And secondly, how much memory is available. It has to find out how much memory is available in that system to find out if that operating system can be installed in that system. And even if it is installed, how can we allocate the memory in such a way that it will work in a good and efficient way? And then the third thing is what devices are available. So the system program has to determine what are the devices that are attached to this specific machine and what are the models of this and how it is connected to the machine. So by knowing all this, the operating system will be able to function properly with the devices that are connected to that particular machine. And the fourth thing is what operating system options are desired. So the system program has to find out what is this machine intending from the operating system. That means what does this system want operating system to do? What are the kind of functions this system or this machine wants? So the system program has to find out what are the operating system options that is system wants, so that depending upon that, it can generate the operating system for that particular task or set of tasks. Then this machine wants the operating system to work so that is how the system program helps in generating the kind of operating system that is required for a particular machine. So it determines all these things, and depending upon this, operating system will be generated for that particular machine. So that is how the operating system generation works. Now let us go to the next topic, which is system boot. Now we come to the next topic, that is system boot. So what is the system boot? You must have heard this term booting many times, so you must have heard people saying, boot your computer, or reboot your computer, and so on. So what is the meaning of this term booting? So the procedure of starting a computer by loading the kernel is known as booting the system. So after everything is ready, when you are going to start the computer, the core of the operating system, which is the kernel, has to be loaded. And it is at that time your computer starts up. So the process of starting the computer by loading the kernel is known as booting the system. Now the question is, how does this happen? You have the hardware, and you have the operating system installed, and everything is ready. Now the kernel has to be loaded into the memory. But the hardware itself doesn't know how to load the kernel or how to locate the kernel and how to load it into the memory. So how does the system booting takes place? So for that, we have something known as the Bootstrap program or the Bootstrap loader. So on most computer systems, a small piece of code, known as the Bootstrap program or the Bootstrap loader, locates the corner. So the function of this Bootstrap program or the Bootstrap loader is to locate the kernel and help it to load it to the memory, because the hardware itself does not know do it. So this is a very important program. That is the Bootstrap program or the Bootstrap loader. This is the first thing that starts up when you switch on your computer. So this process is known as booting. The Bootstrap loader helps to locate the kernel, and it will help to load that kernel into the memory, and thus starting up your operating system. So that process is known as booting. Now this Bootstrap program, or this Bootstrap loader, it is in the form of read-only memory or ROM, because the RAM is in an unknown state. At system startup, ROM is convenient because it needs no initialization and cannot be infected by computer virus. So this line tells us, where does the Bootstrap program or the Bootstrap loader reside in your computer system? So it is in the form of a read-only memory. So I've already discussed this. Types of memory. We have read-only memory, which is ROM, and random access memory, which is RAM. So I already told you, RAM is volatile in nature, which means that the contents of the RAM are always erased, or it is lost when the power to the RAM is switched off, but the contents in ROM are never erased. It remains in it all the time. So the Booster program, it is in the form of a read-only memory. And why is it in read-only memory? Because this is the first program that loads when you start your computer, and it has to be always there, and it has to be always ready. But if you store it in the RAM, what happens is, as I told you, RAM is volatile. So when the power is gone, the contents RAM is erased. So when the system is just starting up, we do not know in what state the RAM is in, but the ROM is always ready. The ROM always has its contents in it, no matter there is power or not. So the Booster program is always there in the read-only memory, because it always has to be in a consistent and ready state. And ROM is convenient because it needs no initialization and cannot be infected by computer virus. So why does it say that it cannot be infected by a computer virus? So what does a computer virus do? When a computer virus infects the system, it tries to modify something or manipulate something so that something does not work, or something starts working in a different way. That is what a computer virus does. But if your Bootstrap program resides in the read-only memory room, from the name itself, it says it is a read-only memory. The contents of this room can only be read. It cannot be modified, so a virus cannot do anything to the read-only memory. All right, now there is another term that I want to discuss. That is called firmware. So you must have heard this term, firmware, in your mobile devices, in all which says update your firmware, or your firmware is of this version. So firmware is also a kind of read-only memory. And in small devices, like your mobile devices, the Bootstrap loader or the Bootstrap program and the operating system, both of them resides in the room or the firmware. But the disadvantage of this is that If you want to change something in the room, then you have to change the entire room chip, because we know that nothing can be modified. But this problem also has been solved by something known as EPROM EPROM, which stands for erasable, programmable, read-only memory. So this is also a kind of ROM read-only memory in which the content can only be read, but by giving an explicit command, you can make it writable. So, with your consent, it can be made writable. So, the kind of firmware where the booster, blower, and your parenting system both reside in the room are used for small devices like mobile devices, and all for most of the big computers like your desktop computers or your laptops. The bootstrap program bootstrap or the loader, it recites in the room, and your main operating system that recites in the disk. So the bootstrap loader helps in locating the operating system or the kernel of the operating system and helps to load it into the memory. So that is how most common computer systems work now. When the full booster program has been loaded, it can traverse a file system to find operating system kernel, load it into memory, and start its execution. It is only at this point that the system is said to be running. So when the full booster program has been loaded and it locates operating system kernel and loads it into memory and it starts execution, at that point we said that your system is running. So first we booted the system, and for booting, the bootstrap loader or the bootstrap program was helping us. And once the bootstrap loader finds the kernel or locates the kernel and loads it into memory and starts execution, then we say that our system is running. So that is how the system comes from the booting stage to the running stage. I hope that was clear. So there was a board system generation and system boot. So I hope this lecture was clear too. Thank you for watching, and see you in the next one.